Even this question is not difficult. 68. 10 ml of 0.55 molar solution of lead nitrate is mixed with 9 ml of 0.15 molar solution of sodium sulfate. What is the mass of lead sulfate precipitated? Okay, so how do you approach this question? There will be an equation of reaction, just like most chemistry questions, okay? But I think, just like we've been playing this game, we would usually convert this molarity and volume to moles, right? So we're going to do that for the first one, which is the lead nitrate, and also for the second one, which is the sodium sulfate, okay? So let's do that. That sounds like fun. So number of moles of PbNO32 would be concentration multiplied by volume. So that would be 0.55, that's the concentration. And I'm multiplying it by the volume I have there, which is 10 ml. But I'm not just using 10. I have to divide that by 1,000. Tell me why in the comments. Why am I dividing that by 1,000? Alright, so when I do that, I would have 0.0055, I believe. Yeah, in moles. When I solve everything. And then similarly, let's do for Na2SO4. So what's it going to be? Concentration, 0.15, multiplied by the volume, 9, right? Again, I have to divide it by 1,000 to tell me why in the comments. And that gave me 0.00135 mole. Now, I've just done this fun stuff, getting the moles. Let's now write an equation of reaction between Na2SO4 and lead nitrate, PbNO32. So if we do that, the sodium would react with the nitrate part to form sodium nitrate, and then the lead would react with the sulfate part to form lead sulfate. Okay, lead 2 sulfate to be specific. So let's write our product. We have Na combining with the nitrate, combines like this, NaNO3, because the nitrate is usually NO3 minus, and your sodium is usually Na plus. So it just gives you NaNO3. There's no 2 anywhere. Alright, now the other one is lead combining with a sulfate, and I'm going to have PbSO4. Again, the sulfate is SO4 2 minus, and lead is Pb2 plus, since it's lead 2. So when you exchange the valencies, the 2 would cancel out and you'd have PbSO4. That's our correct product. And now let's balance the equation. So balancing the equation, we would find that Na here is 2. So we have to drop a 2 here. And that automatically satisfies the nitrate for us, because nitrate is also 2 on the other side. Can you see that? So now it's making a lot of sense. Everything looks arranged. Now let's go ahead to see what the question is saying. What mass of the lead sulfate is precipitated? What mass of this one is precipitated if these two solutions are mixed? If you're writing this in the exam and then your teacher is really peculiar about the states, then this is what you need to do. Show your states. Sodium sulfate they already told you that they are solutions of lead nitrate and what? Sodium sulfate from the question. So I'm writing aqueous both cases here. Besides, sodium salts are soluble and all nitrate salts are also soluble according to the solubility rules. Okay, now on this other hand, I just said all nitrate salts are soluble, right? So that means this will also be in the aqueous form because it's soluble, whereas our lead sulfate would be a solid here for several reasons. Number one, the solubility rule, and then number two, they are telling you to get the mass that's precipitated, so you know it's going to be solid. Okay, right, our equation is fine. And if we want to realize the mass of sodium that would be gotten, then we need to compare either the sodium sulfate with our lead sulfate or the lead nitrate with the lead sulfate. Okay, so it's either we compare, those things. Now, which one do we do? Of course, because like I usually say, one is right, one is wrong. Our limiting reagent will tell us, right? And you're used to this now. Okay, so the limiting reagent should tell us what's the limiting reagent. Is this sodium sulfate or is it lead nitrate? Well, this is our number of moles here, and this is number of moles here. Our stoichiometric coefficient is 1 on both sides, so when I do my ratio, wouldn't really change anything. I guess in this case, I can judge from the number of moles. So which one is smaller here? 0.0135, 0.005. It's going to be this one here, right? So that's the smaller one, and that's my limiting reagent. This stuff I'm doing here in this video number 68 on stoichiometry, is because the coefficients here are 1. That's why I'm judging based on the number of moles, okay? When you want to get your limiting reagent, you go all the way to do the ratio, which is to divide the number of moles by the stoichiometric coefficient. And the values that you will get, that's what you then, judge by. So whichever one is smaller belongs to the limiting reagent. Okay? That's how you know the limiting reagent. I hope this English language I'm speaking, I hope you are getting it. Or is it confusing? Alright, but in this case, when I do that, I'll be dividing by 1, so it won't really change anything. So I can just say that this one here would end up being my limiting reagent after I do that. Therefore, I'm to compare sodium sulfate with this one. Right, so we can see that 1 mole of sodium sulfate gives us 1 mole of lead sulfate from that equation of reaction. You can see that. So that also means that if we have 0.00135 moles of the sodium sulfate reacting, then it would also produce 0.00135 moles of the lead sulfate. And that has just given me my number of moles of lead sulfate. So all I need to do is to get the molar mass of lead sulfate so that I can say number of moles equals mass over molar mass, and then I can get the mass of lead sulfate. It's easy stuff. So let's do molar mass of lead sulfate. Are you ready? Lead is 207, the sulfur is 32, and oxygen is 16. So when you do all that, you should get about 303 grams per mole. Then you conclude this question by saying mass should be moles times molar mass, and yeah, that would be 0.00135 multiplied by 303, which should give us 0.40905 grams. I'm just going to write 0.40 grams. That is the end of this question. So let me know what you think. Is it easy? Is it difficult? Would it take you a long time to solve? Where would you have made a mistake if you think you might have made a mistake? At what point would that be? Let us know. Alright, so I shall see you on question 69, right? If you're watching this on YouTube, you can click the subscribe button there because more of this is coming your way and you'll be able to see it if you are subscribed. And also, if you want to get like a total package of, all the questions, there are 100 questions, total package that would help you practice your stoichiometry, and you reach out via DM, I will show you how to get it. Please note that when you get that document, it will contain the questions, the answer, and then the link to the video answer. Okay, which is one of these videos you're watching like this anyway. What you need to do is to try to solve the question. You'll see the answer there, so try to work towards the answer. And then if you're stuck, you can check the video, right? That way you train yourself in the skill of working on stoichiometry related questions. I hope this makes sense. It's just a study technique to help you guys. And I'll see you on 69. Bye bye.